Welcome back to week 5, and this week we're gonna just dedicate this entire week for just molecular geometry, because there's a reason being. Some of you may be able to get it right away, some of you may need to work more examples, some of you might need a little bit more instruction from me. So there will be a wide variety of people, and that's why I don't want to rush through things and keep it very simple. So molecular geometry, on the other hand, is a little bit tricky over electron geometry, because in electron geometry, we treated the lone pairs as bonds. So we always ended up with 2, 3, 4, 5, and 6. So 2 is always linear, right? 3 is always trigonal planar, because this is number of bonds you have, right? 4 is always tetrahedral. 5 is trigonal bipyramidal. And 6 is octahedral. Now it was simple, because every time we had a lone pair, we counted the lone pair as a bond, which helped us, right? But on the other hand, when we think of molecular geometry, it's slightly different. It's not as straightforward as treating a lone pair as a bond, and it can lead to a little confusion, because if you don't, well, you do have to memorize, but I'll tell you which ones you do have to memorize. So let me erase these so I have my space to do some examples. Good. All right, so with that said, let's look at, we looked at AlCl3, right? How about we look at PCl3? How you construct everything is the same, even the electronegativity, everything else is same. We just have to make that slight adjustment when it comes to name and determining polarity. Right now, phosphorus is in group 5A, so it's got 5 valence electron. Right? Chlorine is in 7A, so it's got 7 valence electron. Right? Now, as always, we put the element that's least in count at the center. So phosphorus goes at the center, and it's got 5 valence electrons. So go ahead and evenly distribute them across. And then the chlorine, each of them has 7. So I'm going to cut straight to the chase. So 7 electron means we have pairs of 2. Right? So nothing much has changed in terms of your construction of a structure. I'll tell you exactly where there is that minor difference as we get there. All right, so now let's go ahead and connect the bonds. Now if you notice, we have a pair of electrons left on the phosphorus, right? So let's go ahead and construct our structure. So it's AX3E, right? Now this is quite contrasting to AlCl3. If you go back to the last video in week 4, I said this is AX3, and I said it's trigonal planar. The common confusion students have is the moment they see 3, they completely disregard the E. The E is not there like a parsley on a Italian food, like you just take it and put it away. The E is there for a purpose. So the E cannot be treated like that it has no real purpose, right? Now for a molecular geometry, right, the E has a purpose, but the fact that the E makes it polar, so that has not changed from the previous, and how you assign polarity is also not different. Clearly, if you look at your electronegativity table, I can tell you without even looking at it that phosphorus is going to be less electronegative than chlorine, and the same deal for the rest of them. So overall, the molecule is polar and the bonds are also polar covalent. Why is it polar? Because of the lone pair. Because lone pairs have a key role to play when it comes to molecular polarity. Okay, so AX3 is polar and the molecular geometry is Trigonal Pyramidal. Okay, Trigonal Pyramidal. Okay, so you can see the difference between AX3 being trigonal planar and AX3 being trigonal pyramidal. What it is the AX3 is like a pizza slice, you know, because it's planar. It sits on the face of the table or a plate that you have your pizza in, because there's no lone pair. The moment you have that lone pair, the whole thing sticks out like a pyramid. Okay, I'm not very good at drawing pyramids, but that's what it looks like. You see the difference? They don't look the same. They clearly look different. So the lone pair has an important role to play in terms of the molecule's polarity. So AX3 is, we said, is non-polar, whereas AX3E is polar. So this right here is non-polar, and this is something you may have to memorize. So it's trigonal pyramidal. Okay, let's look at a couple of examples. Okay, I'm doing fine with time, so we're good. So let's go get another molecule. Okay, again, it may not be feasible for me to do every single example under the sky to help you, but I will do my best to get as much of it as down. So water, so H2O. Oxygen is in 6A, so it's 6 valence electron, and hydrogen is in group 1A, so it's got 1 valence electron. As always, the oxygen goes at the center and it's got 6 electrons, so 3, 4, 5, 6, right? And then the 2 hydrogens is you get a different color. Okay, so different color. Hydrogen, it's got 1 electron and 1 electron, right? Very good. So let's connect them, right? Now if you notice, there's 2 lone pairs, right? Now if it was electron pair geometry, what would we write? So this is AX2E2, right? If it's electron pair geometry, we treat the E as a bond, so it's AX2E2. Electron pair geometry would be tetrahedral, right? I'm going to write the electron geometry, whereas molecular geometry is, it's bent. Okay, the same thing is bent, and its molecular geometry is bent. You can see right here. Okay, I don't know if there's an easy way. There's a certain pattern which I will come back to, and then clearly on this two, oxygen is more electronegative than hydrogen, and oxygen is more electronegative than hydrogen. But because of the lone pairs, not only are the bonds polar covalent, but the molecule is also polar, which is why water dissolves a lot of things in the world, and it's considered the elixir of life, because there's so many things that require water in our daily life, and sometimes just being thirsty and be able to drink water just makes you feel better. Okay, so, and the reason being that water can do all that is because of the lone pair. Now if the lone pair had not been there, then that would be a totally different case. So it's always easy to remember the electron geometry. You just have to make that extra effort to remember a few. So it's bent is molecular geometry. So let's continue